Right. Hello. Sorry for the huge delay, but here I am. So let's get started. So this next part, or second part, we will just see how a few additional feature is working in this little tool, and then we can just explore a few things about Arnold and maybe some things about subdivisions and displacements and similar things. So start. So first of all, I want to say that this tool is capable of switching between the proxy and the high-res geometries with these two buttons, but it's a little bit limited. I can show you. So if you import something, maybe, I don't know, maybe we can try the way I try to make this more usable. I'm planning to release a newer version of this, which will be capable of generating automatically the thumbnails and everything. It's under construction, so work in progress. So it's not ready yet, but it can be useful, maybe. So we can find something interesting. I don't know, maybe something like this. Okay. This is also Megascans asset originally, so I will import this one. This is the proxy. Super low res, nothing special. And again, this is just using a standard default shader, so which is switched to standard surface in Autodesk, in Maya. I don't know, a few months ago. So it's not Lambert 1 anymore. It's standard surface 1. So, but it really doesn't matter. It's the basic default shader, so it will not. If you import a proxy, it will not. It will not grow your shading nodes in your current scene. So that's the main reason. So if I just open the browser and dock it in, so there is no new shader here. Okay, so we can render this out. I have a different tool, by the way. Maybe you saw that in the first video. It's called DD Panel. It's not available for the public yet. I have to replace a few scripts here, but after that, after I clean up the whole stuff and rewrite a few things, maybe I can release it. It's super practical. It's really useful. I'm using this all the time. Now I will just use the Skydome button here, which is importing a Skydome light and setting some attributes on it, so we can work with it a little bit faster. So this is a separate tool from this one. Okay, this is available. This is not yet. I have a few. Again, I have a few things I have to fix and replace, but maybe I think this year it will be released, so for free. So it will be awesome. So. But I will not use this, or yeah, I think maybe I try. Okay, I'm so used to it, so it's hard to let it go. Let it go. So I will open the Arnold Render view from the official shelf, Arnold shelf, and I will make sure the save UI threads is set to 3. That means you you keep a few CPU threads for interactivity. So that's it. And after that, they just start the render. That's it. It's really fast. Currently, it's rendering in really low resolution. It's I will set to HD 720. So yeah, so we can see it a little bit better. All right, so you can change this proxy object to the high-res version, which is importing the editable high-res version of the asset. As you can see, this is currently one object because a proxy should be one object, so you can easily copy and transform and scatter and everything. So it's one shape, but the original high-res version of this asset or any asset can be at any complexity. So it can be multiple objects under a group, or it can be a scatter, or it can be anything, basically a VDB, visualizer holder node, or anything. So a container. It can be anything, or it can be multiple assets inside that, maybe a group, or basically a whole scene, or it can be a few other things. So almost anything. So it's really easy to use. In this case, the high-res version of this object is also one object. So when I replace it with the high-res version, I don't have to stop the render, by the way. It's interactive. So if I replace this with the replace with high-res button, it will automatically find the high-res version of this asset and import it and replace it in the correct place and group, and maybe not group, but yeah, maybe I will add that later. So it's just replaced with the original mesh and its original shaders. So if it's using multiple objects and using multiple shaders or materials, it will be there in the scene. All right. So the render actually is just going seamlessly. So the interesting part in this is 4 million polygons. So it's really high res, as you can see. This is a scan from Megascans, which is really nice. Now we can change the material, and there are a few interesting things when you do that. So if I select the object and graph the material, I will dock the Arnold Render view here. Okay, it's easier to so we can see everything while we working with the shaders materials. Also, we can see the hyper shading this way. And I think I don't need currently this browser. So we have a little bit more space this way. Okay. So now you have the correct shader, the original shader, and you can do some overrides and some changes with it. So maybe you want to correct the colors or remap the roughness, or change how the normal map works. Maybe you want to change the intensity and anything else as well. So maybe, I don't know, just put some color correct node here. Maybe color correct. Oh, by the way, there is a lot of really nice nodes in Maya, which is the plugin which is providing those is off by default, I think. So you can go to Settings, Preferences, Plugin Manager, and you can find the LookDev kit plugin in Maya. This is by default, it's here, but I think it's off by default. So you can turn this on and turn the auto load on. So then you will have a lot of extra really nice nodes, which works really well with Arnold as well. So I just plug this in and plug this in. So now we can we can color correct all the nodes. I mean the albedo part. So maybe we can do some hue shifting, which is really ugly. So I will not do that. But maybe we can do some gamma corrections as well. This is RGB separately, so I have to put all the same numbers here. We can write a script to do that, by the way, but that's not the point. Maybe we can do some more interesting stuff. Maybe we can check this is working already or not. It looks like it's not, but maybe we just have to sync the full scene, so update full scene, and maybe we can see the changes. Yeah, so now we updated. Maybe the replacement of the object is just not updated on the fly, which is normal, so you don't have to. Yeah, so now it's working perfectly. So a little bit brighter. Maybe we can change the roughness. We can remap the roughness with a simple remap color node. Just connect this part, and then we just the out color, and then the out color R to the specular roughness, and that's it. So now we can remap the roughness as well. The easiest way to do this, if you select the remap color node and then solo it in Arnold. So now we can see all the actual roughness part, and then we can do some remapping. If you want to have more contrast you can change the input min and max values. So then you have more contrast, so you can see more details, right? And then you want to clamp it or just lower the maximum value or the minimum value. Then you can do that. So after we just disable the isolation mode, and then we can go to an angle where we can see more the reflections, right? And now we can really see what's going here. See? So it's really fast. You can do this on the fly. So the interesting part is this. So how can we keep this this changed material but using the proxy? So in this case, because this is a simple case where the high-res is one geometry and the proxy is one geometry, we can just replace this object with the proxy back, change back, and then we reassign this material to the proxy, and then we have to turn off or turn on, we will see, the material overwrite option. So that's it. So I keep this changed material, and then I select the high-res geometry and go to replace with proxy. It's really fast. So now if we just checking the the Arnold Render, which is going in the background, we will get back the original material, which was in the ASS file. So now we can go to the shape node and go down, and we can reapply this material to the selected object. That's it. So now we changed the material, but we cannot see that yet, okay? We cannot see that yet here, because we have to tell Arnold, okay, please use the material which is assigned in the current scene, not the inside the ASS. So that's it. All right. So if we just select this and go to 222, sorry. For some reason I can't see this. Opaque, shadow, double-sided frame, extension. What is going on? Why I can't see the material part? Oh, because that's inside the Arnold section, of course. So as you can see, this is override standing shaders. That's it. So of course we have to check that inside the Arnold part of inside the mesh node. That's it. So now you can do whatever you want. You can do some more interesting things. Maybe you can create an AI layered RGBA node, which can be used to to layering stuff, maybe textures. So this will be the input one. I will change the operation mode to overwrite. I don't know why it's over the default one, which is doesn't make any sense, because that way you have to think backwards. But this way, the layer one is the first layer, the second layer is the second layer, and this way it will works like maybe in Photoshop in layers. So the first layer is the base one, and the second layer is on top of that. But you have to change the operation type to overwrite. By the way, that's the correct math here. So I don't know why the over is the default one, which is strange. Maybe they try to keep the order, but the numbering is wrong in that way. So that doesn't make any sense. So so you use the layer is the lowest one. The layer one is the lowest one, the second layer is on top of that, but you have to change the operation to overwrite, which is the simple over math. So it's not, if you keep the default one, which is the over, it's more complex math a little bit. So the overwrite is just put this and then top of that put this one, and then mask it with the mix attribute. That's it. So we will do that. So now, okay, we will create a little bit more complex stuff. So not that much. So I will duplicate the color correct node and just connect the original texture, and I put this one into the second layer. And I turn on the second layer and get the overwrite. By the way, the first layer, it doesn't matter which type of operation I have. And then I want to create maybe a noise node or some interesting one. Okay, I will try to do this. It's really simple. So maybe I will go with a simple Maya noise texture, which is in this way, it's using simple UV coordinates, but in this case, okay, go to the mix 2. In this case, it will be enough to see what's the difference. And then I will put the out color to the base color. So if I want to check what the noise is doing, I select the noise node and I go to the isolation mode. So I will see currently what the noise texture actually doing. Where is it masking or not? So I will change this to Perlin noise. I will change the depth max so we can have more details, right? And of course, this is using UV, and because of this is a scanned object. The UV is not that pretty, so it will not be continuous and everything, but in this case for the demonstration it's okay. I want to see this a little bit more, so I will use a remap, if I can write a remap color node, go with the color, and then I can go with the R, the red channel. So and then I can remap this really nicely, maybe this way. All right, so now we will see definitely the difference between the two layers. Okay, that was the point. If you select the AI layer RGBA node, it will also show the mixed results. So I can do an interesting stuff. I can go to render, debug shading mode, and the isolation is on with this button, but you can lock the selection. So that's really nice. Lock selection. So now if I pick another node, it will not change because this will be the node which is isolated. All right. So I can go to the secondary color correction node and I can change a few things. Maybe I can lower the saturation. So maybe the value. So now you can see the masking is working really nicely. All right. So then I just disable the locking part and I disable the isolation. So now we can see the rendering is different. We can do this also with the roughness as well, of course, or you can use this maybe, or similar methods. Maybe you can use an AI layered shader node, which can be used to masking different shaders, which is really nice as well. So that way you can create the 2 separate or 3 or 5 or any number almost shaders, and then you can just use masking nodes to separate those parts from each other. All right. So again, the main thing here is these 2 buttons: the replace with high-res, the replace with proxy, and after that you change the shader after you change to the high-res version with the correct shader, and then you switch back to the proxy, and then in the Arnold section inside the mesh node, you just turn on the override standing shaders, and of course, so OBS is just having some trouble. I hope you see anything correctly. I hope. So that's it. This is the simple, the second part maybe. And inside that the first section. All right, so this is a really nice feature. I think I use this a lot in one of the sample scene I created for the snowy scene. I can show you how that works in there, but basically that's it. There is one caveat: you cannot use this method if you have if the high-res version of the object is using multiple objects and multiple materials and everything. But maybe in the future I will figure a way to do that efficiently. So of course you can do that. You can keep the high-res if you want for some objects, maybe some hero objects and some main modification for one or few objects, but I don't recommend to do that for every single piece of the layout, because then you lose the efficiency which is available with the proxies. Okay, so I will open a previously created scene, which is the Quest Snowy scene, so I can show you a lot of part where I use this one. So this is the scene. You saw the composite and the render on my blog. I will just hide the instancer right now. This is the layout. It's not super organized. It could be better, but it's it's PG, main, midground, and a few special layout elements here. It's not super organized, but it's for this demonstration it was enough, and I can easily navigate through this one. So as you can see, every object is the proxy object, and every object has a different shader inside the original asset. So I can show you. So I modify those with a simple modification. So as you can see, this is using a little bit more complex than this one. So as you can see, I created a simple snow material. All right. this one. This is the mask. This is a snow node. That's a native node in Maya. A simple vert space direction node, which is masking the snowy parts from the base material using the mix 2, as you can see. The first layer is the original layer. So the input 1 is the original shader. I did not change that, but I created this snowy material and this mask. So, and if you want to see, I just do that. So I selected the object. When I created the new shader, I just assigned this one. So if you just select the object, you can see this is using the AI layer shader node. I tried to show that. Okay. Yeah. So the trick is there is a trick here. It's not a big trick, a little trick. Okay. There are way to separate the viewport shader from the render shader inside Maya for almost every render engine I saw. It's super easy. So you have the SG node, which is the shading engine node, which has the surface material input, which is the basically the viewport shader. If you put a different shader inside the Arnold section called surface shader, that's the one Arnold will see and render. And this is the one which will show up in the viewport. So you don't have to do this. I just did this for some viewport stuff, so I can see better the objects, maybe in texture mode. But you don't have to do this. But in this case, I did. So this is the surface shader. This is the layered shader. I render this one. See, it's AI surface shader. That's the input. So this is how I separated the two. Right? So the viewport is just the basic shader, but the layered shader is which is Arnold will render. So that's how this works. So, and that's a simple AI standard surface shader, which it's not super complicated. There are some subsurface stuff here, and the mask it's not textured also. So in this scene, it looked to me it's enough. So I didn't went crazy. So that's it, and this is all the parts is working this way. So if I draw this out, see the same thing, original material for this tree log or something, and of course the override standing shaders inside the mesh node inside the Arnold part is turned on, so it's using the materials in the scene which is assigned to this object, not the one inside the ASS file. That's it. Okay, so I have a terrain here, not a ground. I can show you that. So I will just unparent this and hide everything else. Okay. So I can show this simple, very simple object here. As you can see, this is not using any ASS file. All right. It's not. It's just this object is a ground object. So this is the main part of the scene where everything is sits and layout almost. And this is a Subdiv displacement object. So if I draw the shaders, you see, it's super simple. Of course, the snowy part, so the layered shader and the snow, but I will just ignore that part and I will show you how can you create really nice subdivision displacement grounds. Maybe I will do this in a totally separate way, separate scene. Okay, let's do that. But first I can show you the displacement part and the texture part for this one. Oh, orange means something went wrong and Maya cannot understand the textures inside this graph, so you don't have to worry about this. Sometimes that can happen. I will change a few things maybe. Yeah, it's just interesting because this is using the standard. I know. The AI triplanar nodes, it's the problem. So that Maya viewport cannot understand these nodes, so it went crazy. All right. All right, I think that's the best way is if I create a totally new scene. I can show you. So I put a simple object here. Sorry, I have to use my yeah, I don't have to. As actually, if I go to the sculpting part and I go to the content browser, Maya content browser, I can get the simple humanoid mesh. Not here. Bipeds, that's this one. Okay, so this is a human body, which is correct size, but it's using a strange shader. No, it's not using anymore. Nice. Oh. Very nice. All right, so I have this. See, the size difference is it's huge because this is just a 1x1 size. So I will change that to, I don't know, 500. Maybe 1000. 50-50. So that will be enough for the base resolution, right? All right, I will delete history on this one. And I will import a really nice shader for this one from Megascans, okay? Start with this one. So I go to Home, Surfaces, maybe go to some ground category. That's nice. Okay, we can try this one. I will download this one. Of course, I already set all the necessary settings from the download. It's done, so I will export this. It's converting to the JPEGs to TIFFs and keep the EXR as EXR. So the shader is already assigned to the selected object. It's done. The script is imported, the bump map. Maybe you want to use that for anything, but it's not connected. It's connecting only the necessary stuff. So there are a few things you can check here. There is a displacement offset and a displacement multiply. Float math node, it's both float math. This is practical if you want to see the displacement inside the viewport for the displacement with the displacement preview feature. But this way you can mix the displacement and texture layers more easily. So that's why I use this way. So that means the Arnold part, the scalar zero value is 0, not 0.5. And I don't have to use this way the offset feature inside the displacement node. I mean the texture node for the displacement, because this is already offsetting and this is the multiplication part. So, all right. So this way. So that then you can use the R, the red channel from the displacement EXR file. I can show you in Photoshop what that means. Because by default, the Megascans is using this method, so where the red channel is containing only the data and there is nothing inside green and blue. So this is not a grayscale image. This is an RGB EXR image which contains only data on the red channel. So previously you had to convert this and you have to change, and so there was a lot of workaround. But this way, if you use this way, outcolor R to a float math, which is additive operation, and minus 0.5 the offset, and then the multiplication is whatever you want. Okay, I also have a scale here, which is not necessary, but you can mix the two, it doesn't matter. So this way it will work really nicely. All right. So I can check the textures here, right? The scale, maybe it's not perfect, it's too big. So I will change the place 2D texture node, repeat UV part 4 maybe. That looks better, much better. You can check, of course, the size of the original texture. Here in the Megascans, it's 2 by 2 meters. In this case, I will not go crazy to get the scale perfect. Okay, I mean, it's good enough in this case. So the importer script is also changed a few things in the subdivision part. The type is set now to Catmull-Clark, not none, so it will subdivide. The iterations is just 3 right now. The adaptive error is not turned on, it's 0. All right, and basically that's it. So if you want a nice preview from the displacement, you just have to press Alt-3 in Maya. So now you have a displacement preview inside the viewport, which is OpenCL and GPU accelerated adaptive subdiv. You can check that inside the mesh node. You have to go to the smooth mesh part. As you can see, with Alt-3, you turned on the displacement preview button. And then if you go to Open Subdiv controls, you can see the configurations for that. Adaptive tessellation level 7, OpenCL acceleration, and this is a Maya Catmull-Clark version of the UV boundary, and that's it. So there are one more interesting part in Maya, which is you have to know this, okay? So Maya can subdivide objects in the viewport, and that can be rendered, and it will be rendered with Arnold by default. So if I just put one object here, maybe a cube, right, and I can add a few divisions, not much, right? If you press 3, you have the subdivision preview, and if you try to render this, it will render like this, okay? Because the subdivision preview is turned on. See this one, all right? And the preview division levels is 2. You can turn on the display of the divisions. See, it's not super high, but it's, you know, something. You can change this to anything you want. So, I mean, you can go crazy, but be careful. The GPU has limited memory, of course, as everything. So if I go to the preview level with 1, and then I turn off the use preview level for rendering part, which means now you can separate the two. So now you can have a 0 preview divisions in the viewport, and then you can have anything in the render. But this subdiv level is separated from the Arnold one. All right. If you use both, you will render both. So if you set the iterations number, the type maybe for Catmull-Clark, iterations 3 in the Arnold section, and also you have a render division levels in the smooth mesh part, maybe 2, that means it's 5. So 3 plus 2, that's 5. That means you will have a lot of polygons. So if I just check the basic one, so it means 54 faces, right? And we do the math, so super simple math, right? So 54 times every face, every quad will be, you know, divided by 2. So you have to times 4, and you have to the power will be 2 plus 3, that's 5, so that means that will be 5 something. All right, so 5500 and I mean 55,296 polygons. So that's that's not the same as if you know the power is only 3 or 2. So you have to pay attention to this. So my best recommendation is just not using the render part. So you just turn this off and set this to 0, right? So then you can use anything in the preview, right? And totally independently, you can change the render version of it. So if you want to 5 in the render, you just put 5, and because this is 0, it will render as 5. So it's not you know, 0 plus 5, that's 5. All right. Okay, so that's important. So I will hide this. So go back to this one. So it's using, see, you use preview level for rendering, so that should be 0, right? The preview for the viewport is 1, which is okay, because we need at least 1 so this can work, right? So if I just put 0, this is not doing anything. So if I go to 1, this is now working. All right, so you can see really nice displacement preview here. All right, so that's it basically. So now we can try to go first with maybe 5 or 4, and then we can go anywhere from there. So if I go, maybe I go to the render view, I will close this one, and I start rendering. So first, now of course we have to wait for the first time those textures are used the first time. So Arnold will convert those textures into TX files, which is a really nice map version of the textures. So it will be faster to render, and it will use less memory. And also, of course, we don't have any lights, so I will add some lights. Okay, but the render is finished. So if you go to the basic shading in the utility shader section, so this is shading. We don't have lights, so we cannot see anything. But you can go to basics. So now you will see the Subdiv displays shaderless version of the geometry, all geometries. You can go to wireframe. You can see the resolution of that. So we can see the basic resolution is just really low, and we can add 4 iterations to that. So it's not super much. So it's not that much. But now we can go further. So when we go 5, now you have to see interactively the displacements. So now we can go 6. And of course you can see the use memory. It's a little bit more, so it's more than 5 gigabytes of RAM. If I then go to basics, you'll see it's getting really nice. So again, you have to remember the viewport preview, all right, is using adaptive 7, and now we using not adaptive because the adaptive error is 0. We're using non-adaptive 6. So, but we can optimize this further, and it's getting better. The preview and the rendering is really similar. So I mean, if you have a correct texture input, that means a 16 or 32-bit image as a displacement, the preview will be exact. So as you can, I don't know, how can I prove that? So if you just go here, the same clip is there. So if I change the offset, maybe, so I lower the part, the render should doing the displacement and subdivision part, and after that it should be updated. No, it should. Strange. Maybe I have to resync this update further. Whoa, it's not working. All right. Oh, it's working. It was just too fast. Sorry. So, sorry. Okay, now it's doing, okay, it worked. So I have to wait the displacement. You can check the log if you want. Oh, it's done, see? You have to wait, of course, the subdivision, because the subdiv and the displace change because of the subdiv, not necessarily, but the displacement is definitely changed. So you have to wait for, again, for the geometry to subdivide and to see the results, but it was just a few seconds. So, but we can optimize that further. So if I go back to minus 0.5, which is, it should be, so if you have a texture, which displacement texture, which has, you know, this is the mid-gray colors in it, and all the increasing part is more bright, and all the decreasing part is more black or darker. That means you should have, in theory, this value in here. So, but sometimes the baked displacement map is not correct, so you have to choose a different one. But you can, if you just stop the render, so you can just see the preview. This is why the preview is so useful, because now you can see that in real time the offset part, and then you can see the real time the intensity part. So it's really useful. Actually, this is super useful when you try to do this scenario where you have to check the displacement and the connection between maybe a animated character and the ground. So that's super important. All right, so how we can optimize this further? So I just start the render. All right, so the log is empty because the default settings here is just putting the errors here, not all the messages. So another tip for Arnold users is really useful. You can go to the diagnostic part, and this you can change to info, and now you can see everything which is Arnold is doing, almost everything. There is a debug part which is more information, but now you can see everything. So it says, okay, this is broken, this is broken. You don't have to worry about that right now, but you can see here is everything which is Arnold doing. So this is actually not broken. So all right. So you can see the subdiv, the memory, if you try to do this more optimized version, you can do this, right? So now we can turn on the adaptive error part. So that means, so the adaptive metric is important. Auto means Arnold tried to guess. In most cases, the edge length version is the better one. So you have more details, and you have also optimized the geometry, which is then it can use less memory, which is good. So, but I will leave this right now in auto, and I put an adaptive error at 3. It's automatically rendering right now, so it's done. As you can see, there is not much difference in the images, the result, but if I go to the wireframe, you will see a huge difference. So that means, if by default this is edge length based, I mean, in this case I can see. So if you go here, you will get the same in this case. So that means edge length based, so it will check after subdivision. Arnold will check the resulted edges length, which is generated in the subdiv process, and if it's it's less than 3 pixels, it will not subdivide anymore that part. So that means if I increase this value, maybe 5, you will see in the foreground it's the same subdivision, but in the background you get less and less and less based on the distance of the camera. And of course, because it's pixel related, the resolution will change this as well. So you don't forget that, okay? So if I go to maybe 8, and I go with the adaptive error with 3, I will get really high-res geometry close to the camera, and not that much high-res in the background. So I have to wait a little bit because this is all right. This is really heavy stuff. Okay, so now if you check super high-res close to the camera, right? So if I go to the basics, see, this is not normal map, this is not bump map, this is not anything like that. It's just if you go to the auto bump is also turned off in the displacement shader node, and it is turned off in the geometry as well. That means this is the pure displacement and subdiv results. Okay, so it's super high res, right? But in the background, the resolution is decreasing by the distance based on those settings. So adaptive error 3, that means again, if the edge length is less than 3 pixels, it will not subdivide it anymore. So if I go to 4, I will optimize this a little bit further. I think I will not lose any details here in the foreground. Maybe I have, because this is so much resolution. So you have to figure this out. Okay, you have to check it. And of course, this is based on camera, so you need the actual camera to check this out. If you try to move the camera right now, you will see. Okay, this is maybe too back. Okay, you will see the divisions in the wireframe mode. You will see the divisions. So the adaptive displacement, adaptive subdivisions is not updated while you're changing the camera position. Okay, you have to restart the render to see that. That's super important. Usually in production, that's not an issue at all because every frame is rendered separately. So that's it. But if you want to check the details with a different camera position, you have to restart the scene. I mean the render of the scene. See, that's it. All right, I hope this will help you to get further. I will just put a nice IBR here so we can really see what's going on. I will turn off this. Okay, it's already turned off. Turn off this Arnold render view, and for the demonstration purposes, I will render this in the viewport. You can do that really easily. There is one super important thing you have to remember. You see, this is the 3, which is, maximum CPU threads you have -3, so you can have interaction, really nice interaction with the scene while rendering. This is not considered when you're rendering in the viewport. I don't know why. It's strange. So if you want to set that manually, you can do that. You have to go to the system part, and there is one settings. It's called auto detect threads. You have to turn this off, and I have 24 threads, so I will use, maybe because I am streaming while I'm doing this, so I have to use a little bit, so I will use 18. Okay, of course I have a script for that, so for convenience, but so now you can render this in the viewport. So it's super easy. This is the Arnold Render button here. You just press that, and it will do the subdivision and the displacement, and then rendering. So also, okay, it's really fast, by the way. All right, so that's it. Again, this is really fast, but don't forget, if you can check the wireframe here as well. If you change the camera position, see, the adaptive displacement is not updated automatically. So you have to stop and restart it, so you can have a new adaptive version of this camera angle, right? This camera position. So it works really nicely, really fast. So I recommend you to do this. As you can see, if I just turn this off and on, so I can have the really nice displacement and the subdivs. Just a sec. Okay, really nice. You can cheat this a little bit, and this is my last recommendations. You can lower the iterations, maybe I don't know, 5. You can keep the adaptive error bit. I will have a nice tip for that. I just don't have to forget it. So there's one more trick. There is a feature in most render engine. Arnold have it also, called auto bump. Not every render engine goes this way, but auto bump means if you have a displacement, right? In this case, we have. Arnold will check what's the result, what's the difference between the guessed, not guessed. That's a different word. Sorry. So guessed, but guesstimated displacement result and the actual one. So that's a simple calculation from the Arnold. It's not super complex, so it really fast, so it will not slow your rendering part. So Arnold will check the displacement texture and it try to guess, okay, at the current rendering is how different which I calculated from this in theory. And then it tried to use that displacement in that detail frequency which is necessary as a bump map. So it sounds complicated, but it's really not. So if I go to basic debug shading mode and I turn this on, you will see the bump map is showing up on the subdiv and displaced surface. And of course, you will see that in the render as well. So this is a nice trick. Sometimes, maybe if you have a little bit further from the scene, right? A few meters maybe. I just restart this for the adaptive part. Oh, I turned the adaptivity off, so it doesn't matter anymore. You can see it's sometimes it's enough to have auto bump, or you have a little bit nicer normal map. That's also possible to mix the two, but you have to be careful because you don't want to mix the two in that way where the normal modulation is doubled, right? So if you have a normal map which is not high frequency normal, in this case it's not. So if I just open in Photoshop quickly, right? You see this is the same normal modulation data, right? If you have a really simple plane and you put this normal map on it, you will see not the same as, of course, the displacement map, but the same result, but faked, right? But that means if you have displacement and subdivs, the geometry is already distorted, right? And moved, the actual vertices are moved to certain places in certain distances, right? So you don't want to mix both because that will result. So I have a normal which is now, it was flat before, so it was in the y direction. Now it's displayed, so it's now that point is just the normal is facing this direction, maybe in the left a little bit, right? But if you're using the same normal map, which is doing that for the flat surface, you will just turn off the normal direction from the surface into a negative value, which is, you really don't want to do that, right? So if you try to composite that render, okay, you will have really angry compositors, okay? So you don't want to do that. All right, but auto bump is also can be dangerous if you have too much intensity. It can be too much as well. So actually, this auto bump feature is considering the intensity of the displacement. So this can be also too much. As you can see, in this case, maybe it's a little bit already too much, right? So it's try to, you have really really darkened surfaces, which without this you cannot see. Okay, now it's not, you know, enough resolution, but if I bump this up and bump this back to 8, which means, all right, so now it will be really, really detailed and only with displacement and subdiv. See, you don't see those really darkened parts because the normals now are totally correct. And this is what you want to see or approximate with auto bump or normal map. But yeah, so if I render this correctly, see, there is no strange darkening anywhere. It works perfectly with the light, all right? So you have to be really careful with the auto bump and the normal map while you really, you know, subdividing and displacing the surface. So that's super important. Okay. I will talk this about later maybe. This is also true for characters and everything else. So this is not, you know, specific to simple planes like this one. Okay. As you can see, it's really, really nice. All right. So that's it. If you have any questions, you can find me, of course, in the YouTube channel. I try to answer every question, okay? Not guaranteed, but I try, and you can find me at my blog. So next time, I think we put together a really complex scene. Maybe a saloon or something, in a more interior oriented stuff. Okay, we'll see. I try to be not as you know. So I think it's 6 weeks or 5. So I try to be maybe 2 weeks, okay? Be available. All right. Thank you. Have a nice.